Alright, we're looking at page 301 in our RAPs. We're going to start with problem A. Question A says a rest stop is 15 kilometers away. How far is the rest stop in miles? Use the following conversion. 1 mile is 1.6 kilometers. So we start with 15 kilometers and we need to convert it to miles. So the key here is to cancel out the kilometers by using the conversion they give us. Knowing that, we need to make sure that if the kilometers we have currently is on top, we need to write our kilometers on bottom. So we're going to rewrite our conversion as 1.6 kilometers on the bottom and 1 mile on the top. That way we can cancel out our units of kilometers, and then we can just multiply straight across. 15 times 1 is 15. And then we're going to have 1.6 in the denominator, and our only units that are left are miles. Now remember, a fraction bar also represents division, so at this point we can do 15 divided by 1.6, and we'll just be left with 9.375 miles. And that's it for question A. Let's take a look at B now. B says that a girl weighs 130 pounds. How much does she weigh in kilograms? They also tell us that the conversion is 1 kilogram to 2.2 pounds. So if she weighs 130 pounds, we need to make sure that our conversion cancels out the pounds in order for us to get to kilograms. So 2.2 pounds is going to go in the bottom of our fraction, and 1 kilogram is going to go in the top. This will allow us to cancel out the pounds. 130 times 1 is 130. We end up with 2.2 in the bottom, and our units that are left are kilograms. Now we can just do 130 divided by 2.2, and that leaves us with 59.09 repeated. So I'm going to write that repeat bar over the 09. And we will have kilograms as our units. Okay. All right, here's C. A car is traveling at a rate of 70 miles per hour. What is the car's rate in miles per minute? So starting out, we have 70 miles per hour, which means 70 miles per 1 hour. And we need to convert hours to minutes. Now, they don't tell us the conversion here, but hopefully you realize that there's 60 minutes in an hour. And since we want the hours to cancel and our hours are currently on the bottom, we need to write 1 hour on the top and 60 minutes on the bottom. So this will allow our hour units to cancel, and on the top we have 70 times 1, which is 70, 1 times 60, which is 60, and our units that are left are miles per minute. And we're going to need to divide 70 by 60, and that leaves us with 1.16 with the 6 repeating, so we put that bar over it, miles per minute. Question D says, as Saturn revolves around the sun, it travels at a speed of 6 miles per second. Convert this to kilometers per second. At this speed, how many kilometers will Saturn travel in 5 seconds? Use the following conversion. 1 mile is 1.6 kilometers. So there's 2 parts to this question. First, we have to start out by converting 6 miles per second. and we want to convert it to kilometers per second. And they tell us that 1 mile is 1.6 kilometers. So if miles is currently on the top, we want to put miles on the bottom in order to cancel it out. And we know that 1.6 kilometers isn't a mile. So that's going to let us cancel out our miles. And now we need to multiply. 6 times 1.6 is 9.6. And 1 times 1 is 1. So we have 9.6 over 1 kilometers per second. And when we divide 9.6 by 1, we just get 9.6 kilometers per second. Now that only answers the first part of the question. To answer the second part of the question, which asks how many kilometers will Saturn travel in 5 seconds, we need to multiply 9.6 by 5. And that leaves us with 48 kilometers. Okay. One more question to go. We have question E to look at still. A triathlete rides his bike at a speed of 26 kilometers per hour. What is the speed in meters per second? How many meters will the triathlete travel in 3 seconds on his bike? Do not round your answer. So this one also has 2 parts to it. It starts out with 26 kilometers per hour. And it wants us to get to meters per second. Now notice it doesn't give us any conversions here. It expects us to be able to convert within the metric system, and it also expects us to know our time conversions as well. So hopefully you've memorized some little silly mnemonic device to help you memorize the metric system. And you hopefully know that in order to get from kilometers to meters, you have to move your decimal point 3 times, which means that there's 1,000 meters in 1 kilometer. So we can use 1 kilometer is 1,000 meters. And we'd want to put the kilometers on the bottom there in order to cancel out with the kilometers on the top. So that gets us to meters, but now we still need to get from hours to seconds. Now there are 60 seconds in a minute, and there's 60 minutes in an hour. So we're going to have to do this one in 2 pieces. So first we can say that 1 hour has 60 minutes. And I put the hour on top there in order to cancel with the hour on the bottom. And now I can also say that there's 60 minutes. Oops, I said that backwards. That, excuse me, that 1 minute has 60 seconds. And I put that minute on the top in order to cancel with the minute on the bottom. So let's see what we have here when we multiply across. There was a lot of conversions in this one. 26 times 1,000 times 1 times 1 will give me 26,000. 1 times 1 times 60 times 60 will give me 3,600. And I have left in my units meters per second. And if I divide 26,000 by 3,600, I have 7.2 repeated meters per second. Now that just answers the first part. It says, how many meters will the triathlete travel in 3 seconds on his bike? So I then need to multiply that by 3. And that gives me 21.6 repeated meters. Okay. I hope that helps you on page 301. It's all about canceling out those units top to bottom and being really careful with those conversions. If you have any questions at all, please don't hesitate to contact me, but be proactive about it and contact me sooner rather than later. Don't wait until the last second to ask for help. I'm here to help you though. Please remember that, and we'll get through this.